Hi, my name is Alice Zhang, and this video is for our team members, which include me, Thomas Slay, and Muhammad Ali. This video will explain and go over our protocols from labs 1 through 3, and we will explain throughout what we learned in each lab and what we got out of it. In Lab 1, Autonomous Vehicle Lab 1, where we learned how to navigate the Jupyter Notebook and Python programming. We developed a fundamental understanding of how to program and control a autonomous vehicle, in our case, which would be the JetBot, using Python and kinematic principles. First, we learned how to use the notebook, which would include running the code, using the libraries, and just interacting with the robot throughout the commands. This would directly allow us to control the JetBot's motions and motors and understand how the software works, translating it into the physical movement.
In Lab 2, we use basic image processing techniques, a path-following controller, and a model for image classification to move our JetBot around a track and recognize stop signs, speed limit signs, and scenarios where no street sign is in view. First, we built a circle using road maps to simulate straight stretches and turns. We then needed to train the JetBot to identify where the center of the road was. To accomplish this, we adjusted the HSV values to ensure it could pick up the center of the line on the mats. Next, we used NVIDIA's interactive classification tool to collect data and train a predictive model using a transfer learning method to classify different road signs. To do this, we had to place the JetBot on various places on the mat and angle the camera all around to ensure the predictive model was confident in what it was seeing at all times. After training and testing our data, we achieved a score of nearly 100% probability for all three cases at various angles and distances from signs.
In Lab 3, we used a second JetBot to detect the position and direction of the first JetBot on a road map using AppleTag markers. First, we capture multiple images of the bot from different angles. This helps us get better samples for calibration. Then we run the code to compare images with distortion and without distortion, so we can correct the camera view. Next, we place the first JetBot at different locations on the road map. The second JetBot detects its coordinates and orientation in real time. Finally, we perform path planning using node calculation. We determine the shortest path between 2 points by selecting the best nodes and direction. The node coordinates are shown in Jupyter Lab and the path is visualized on the roadmap, while the red line indicates the direction the JetBot should follow to reach the destination using the shortest path. In this lab, we combine three parts from the previous labs: path following, sign recognition, and kinematics. First, for path following, we use the sample code from Lab 2 and modify it so the JetBot can follow the line smoothly. It can move along both straight and curved paths, and as long as there is a visible line on the road, the JetBot will follow it regardless of the direction. Next, we implement sign recognition. We train the model 30 times with 10 inputs, each to improve its accuracy. As shown in the video, the JetBot is able to detect different signs, such as the speed sign, stop sign, and no sign. The prediction updates in real time as we change the sign in front of the JetBot. Then we apply kinematics. This acts as a backup system. If the JetBot fails to detect any sign, it will still continue moving based on predefined distance. It will stop automatically once it reaches the final distance we set. Finally, we combine all three parts together. As shown in the video, the JetBot first follows the line on the road. While moving, when it detects a stop sign, it pauses for a few seconds before continuing. After that, using kinematics, it moves forwards until it reaches the final destination.
After combining all these functions together in a single code and successfully completing the task in the final lab, we were able to reflect on our work throughout the final module. During the final days in the lab, the team developed a flowchart to help visualize programs and processes. We used the path planning program from the previous section and built off of that to combine all the functions of the JetBot up to that point. In addition to completing all the requirements in each lab in Module 4, we were also able to complete the bonus section in the final lab, showing a deep understanding of the material we had been working on for the last couple of weeks. Overall, we were very satisfied with our work and felt that we gained a lot of knowledge from this experience.